Okay, let's have a look at question 1. Okay, so question 1 is dealing with data handling, so it's calculator work that you're doing. Okay, so it says a bakery keeps track of record of the number of loaves of bread that a tuck shop orders daily over 18 days. Okay, the information is shown in the table below. 18 blocks, each block represents the number of loaves bought in a day. Okay, so 1.1.1 says calculate the mean number of loaves of bread ordered daily. Okay, so the easiest way to do this is just to plug everything into your calculator. Okay, so what we do is we go setup, we go number 3 stat, okay, and then we choose 1 var, okay, and then we just put in all the data there. So once you put in all the data there, then all you do is you push AC. So don't push on or anything, just push AC for clear. Okay, now what we're going to do is we're going to go shift 1, okay, that enables the stat function, and then what we want is number 4 var. Okay, so we click number 4, and there gives us our mean value, and that's x bar. So if I push 2 and equals, it gives me my mean of 22. Okay, so x bar equals to 22. The other way you could have done it is x bar equals to the sum of all x values from I equals 1 to 18 divided by 18, and you would have also got 22 as your mean. Okay, now the next one, 1.1.2 says calculate your standard deviation. So again, we're going to push clear, we're going to go shift 1, okay, and then what we're going to do is we're going to go 4, okay, and then we're going to look here at let's see, 3. Okay, there we go. So 3 gives us our standard deviation of x. Okay, so that funny little symbol over there of x is our standard deviation. So over here we're going to get 10.17. Okay, so don't use this one over here. Let me just clean the screen. Okay, so if I go var, don't use standard deviation. S doesn't stand for standard deviation. Okay, that's got to do with sample and population, which you guys don't do yet. Okay, so it would just be number 3. Okay, now 1.3.3 says the number of days on which the number of loaves of bread ordered was more than 1 standard deviation above the mean. Okay, so what is standard deviation? So I've drawn a little graph here. Okay, this is what an ideal distribution of data would look like. It's called a bell graph. Okay, so we always want it to look like this, but in actual fact, sometimes our data normally looks something like that, or the other way around, where it looks something like that. Okay, so, and then this would be your mean, and that would be your mean. So 1 standard deviation talks about how far is your data distributed from the mean. Okay, so normally majority of your data sits within 1 standard deviation of the mean. Okay, so we've just calculated what standard deviation is. Okay, so that's 10.17, and we want to know how much sits outside of that 1 standard deviation. So what we do is we take our mean and we add our standard deviation. Okay, so what we're going to do is we're going to say x bar plus standard deviation, 1 standard deviation, okay, which then means we're going to have 22 plus 10.17, which then gives us an answer of 32.17. Okay, and that's how much sits outside of 1 standard deviation. Okay, and if we go and look at the table over there, we shall see that 32.17 is roughly about 5 days. Okay, all right, and that's how we do 1.1.3. Now, if we look at 1.2, it says the tuck shop owner was not able to sell all the loaves of bread delivered daily. Okay, he calculated the mean number of loaves sold over 18 days to actually be 20. Okay, calculate the number of loaves of bread which were not sold over 18 days. Okay, so the average total sold. So we're going to look at how much was actually sold on average. Okay, so we take the average, which is 22, which is the mean, and we're multiplying it by the number of days that bread was bought. Okay, that is going to give us an amount of 396 loaves of bread on average that was bought over the 18 days. Okay, but now the tuck shop owner realizes that he only sells 20 as his average, okay, over 18 days. Therefore, he actually only sells 360 loaves of bread in 18 days. So now, if we want to calculate how many loaves he did not sell, we take what we've just calculated, the new average, okay, what he actually sold, minus it from the amount that he bought. Okay, so 396 minus 360 gives you a total of 36 loaves of bread that were not sold during the 18-day period. Okay, now let's have a look at 1.3. Okay, 1.3, they've given you two box and whisker diagrams there, and then it says one of the two box and whisker diagrams drawn below represents the data given in the table above. Okay, 1.3.1 says which one of the following box and whisker diagrams represents the data in the table. Okay, so now what we're going to do is we're going to go back to our calculator. Calculator does amazing things. We're going to go Shift 1, open stat, okay, and then if your calculator has it, we want to look at this number 5, the distribution. Okay, so if I click number 5, okay, oh sorry, not number 5, my bad. Shift 1, not distribution, we're going to look at min and max, so number 6. Okay, min and max gives you all the data you need in order to draw your box and whisker. We've got the minimum value, the maximum value, the first quartile value, the third quartile value, and then the median. Okay, if your calculator doesn't do this, then you'll have to do it by hand. Okay, so by doing it by hand, we can see that there are 18 days, which is an even number. So therefore, in order to find the median, okay, we are then going to have to take the two middle numbers, add them together and divide them by 2. Okay, so if you look at the table there, your two middle numbers will be 18 plus 18, okay, divided by 2, which means we're going to get a median of 18.5. Okay, now the median is the easiest way to determine which box and whisker diagram we're dealing with. Okay, so the median is always represented by the middle line inside of the box for a box and whisker diagram. So this middle line here is your median. Okay, so by looking there at graph A and graph B, we can see that graph B will be our box and whisker diagram that then represents our data. Okay, so it's graph B. Okay, and then they say write down a reason for your answer. Well, we've just shown that the median equals 18.5. Okay, now the last one asks you 1.3.2, describe the skewness of the data. Okay, so the skewness of the data is asking what does my data look like. Okay, so remember I said ideal. Okay, this would be non-ideal situations. Okay, fortunately this is what Marx looks like. Okay, so skewness means where is most of the data sitting? Is it sitting more to the right, more to the left? Is it positively skewed or negatively skewed? Okay, so in this case, just by looking at your box and whisker diagram for graph B, okay, we can see that the larger bar on my box and whisker diagram is sitting to the right. Okay, therefore my data is skewed to the right. So therefore 1.3.2 means, or the description is, that the data is positively skewed. Okay, and that's how we do this work with our calculator. Okay, if you did find this maths video helpful, then please go check out the other maths videos. If you have any questions, then please leave them in the comment section down below. I'll get back to them. If you are enjoying the videos, then please leave a thumbs up on the video. It does help me out a lot. Consider subscribing to the channel as well. And remember, it's never too late to have an OSE moment.